High above the Atacama Desert in Chile, a remarkable new observatory is beginning to change the way humanity watches the night sky. The Vera C. Rubin Observatory is not designed to stare at one distant galaxy for weeks. Instead, its greatest strength is repetition. It repeatedly surveys enormous portions of the southern sky, comparing new observations with older ones to identify anything that has changed. A star suddenly becomes brighter. An asteroid moves. A transient object appears. A distant explosion erupts. Or something that was visible before simply disappears. This approach transforms astronomy from a collection of isolated photographs into something closer to a constantly updated movie of the universe. The observatory's legacy survey of space and time is planned as a decade-long survey, creating an enormous record of how the sky changes over time. Its powerful camera allows astronomers to observe huge areas of the sky with extraordinary detail, making it possible to discover objects and phenomena that previous surveys could easily miss. And even the earliest observations demonstrated just how much remains hidden. One of the first major public releases contained an extraordinary number of distant galaxies in a single view. Each galaxy represents an enormous collection of stars, planets, gas, dust, and potentially black holes. But the real significance wasn't simply the number of galaxies. It was the realization that these observations were only the beginning. The observatory can also reveal extremely faint structures spread across enormous distances. One striking example is a stellar stream associated with a galaxy. These streams are enormous trails of stars created when gravity pulls apart smaller stellar systems or galaxies. Over time, their stars become stretched into long, delicate structures surrounding larger galaxies. To human eyes, these features might appear almost invisible. To Rubin, they can become clues. A stellar stream can reveal the history of galactic encounters and provide information about how galaxies grow. It can also help scientists investigate the influence of dark matter, whose gravity affects the motion of visible objects even though the substance itself cannot be directly seen. But the observatory isn't only interested in things that suddenly appear. It can also search for things that disappear. This is particularly important when astronomers investigate the possibility of failed supernovae. Normally, when a massive star reaches the end of its life, scientists expect a spectacular explosion. But theory suggests that some extremely massive stars might instead collapse directly into black holes without producing a brilliant supernova. If that happens, the star could effectively vanish from view. Finding such an event is incredibly difficult because astronomers aren't searching for a bright explosion. They're searching for an absence. A star that existed yesterday may no longer be visible tomorrow. This is exactly the kind of problem a time domain observatory is designed to investigate. Repeated observations allow researchers to compare the same regions of the sky and identify unusual changes. And then there are the objects much closer to home. Rubin's enormous survey area makes it exceptionally useful for discovering asteroids and other moving objects within the solar system. Some may be faint, fast-moving, or previously unknown. Others could potentially pass relatively close to Earth. The observatory therefore isn't simply looking outward toward distant galaxies. It is also watching our own cosmic neighborhood. Every night provides another opportunity for something unexpected to appear. And that may be the most important part of Rubin's mission. The universe has always been changing. We simply haven't been able to watch all of those changes at once. Now, for the first time, humanity is building an observatory designed specifically to monitor that motion. And if the early observations are any indication, the next decade could reveal a universe far more active than we imagined. For thousands of years, humans looked toward the night sky and saw something that appeared almost permanent. The stars seemed fixed. Constellations returned year after year. Distant galaxies appeared motionless. The universe looked enormous, but from a human perspective, it seemed frozen. The Vera Rubin Observatory is challenging that perception. Its mission is based on repeatedly photographing enormous sections of the sky and searching for differences between observations. That means the observatory is particularly sensitive to motion and change. A tiny point of light can suddenly become important simply because it wasn't there before. An asteroid may move across several images. A distant star may brighten dramatically. A supernova may suddenly appear. Or an object may slowly fade away. This makes Rubin fundamentally different from telescopes designed primarily for deep, detailed observations of individual targets. Its power comes from scale, speed, and repetition. Instead of asking only, "What is this object?" astronomers can also ask, "How has it changed?" That question opens an entirely different branch of astronomy. Consider transient events. Some of the most energetic explosions in the universe are temporary. They can brighten dramatically and then fade over days, weeks, or months. Without repeated observations, astronomers might miss them entirely. Rubin is designed to catch these fleeting events and provide alerts so researchers can investigate them with other telescopes. The same strategy can help scientists study variable stars, stellar explosions, active galaxies, and objects moving through our solar system. But perhaps the most exciting possibilities involve things nobody has predicted. Astronomy has repeatedly shown that the universe can surprise us. Objects have been discovered behaving in ways that forced researchers to reconsider existing models. Unexpected stellar systems have appeared. New types of transient events have been identified. And interstellar objects have demonstrated that material from other planetary systems can pass through our own. A wide-field survey gives scientists an opportunity to discover more of these unusual visitors. The observatory can also contribute to one of the biggest mysteries in modern cosmology, dark matter. Although dark matter cannot be observed directly through ordinary light, its gravitational influence can affect the shapes and apparent positions of distant galaxies. By surveying enormous numbers of galaxies, astronomers can measure subtle distortions caused by gravitational lensing. Over time, these measurements can help researchers construct maps of the invisible mass distributed throughout the universe. Rubin will also investigate dark energy, the mysterious phenomenon associated with the accelerating expansion of the cosmos. The goal is not simply to take beautiful pictures. It is to collect enough data to test fundamental ideas about how the universe evolved. And this is where the observatory's enormous scale becomes important. A single unusual galaxy is interesting. Thousands or millions of galaxies can become statistical evidence. A single moving object is intriguing. Millions of observations can reveal populations and patterns. A single gravitational distortion is difficult to interpret. A massive survey can reveal the large-scale structure of the cosmos. That is the revolution Rubin brings to astronomy. It turns the sky into a continuously monitored dataset. The observatory doesn't need to know in advance exactly what it will discover. Its greatest strength is its ability to notice something unusual and tell astronomers, "Look here. Something changed." That simple message could lead to discoveries ranging from nearby asteroids to distant stellar explosions and perhaps entirely new classes of cosmic phenomena. And there is something deeply fascinating about that. Humanity spent centuries treating the stars as permanent landmarks. Now we have built a machine capable of watching them change. The night sky is no longer just a static landscape. It is a moving, evolving system. Galaxies collide. Stars are born and die. Asteroids cross the solar system. Black holes form. Light suddenly erupts from distant galaxies. And objects from other star systems may pass through our cosmic neighborhood. The Vera Rubin Observatory is designed to catch these moments. So the biggest discovery may not be a single galaxy, asteroid, or explosion. It may be the realization that the universe has always been in motion. We simply didn't have the technology to watch it closely enough. Now we do.